Hi, the internet. You can't see them, but there's a couple of girl students over there right now that are in your video now. I emailed you this, and there's one in your envelope too, so you should have this for today. You're going to want this. It's going to be pretty useful for your educational purposes. Okay, so you tuned in to lesson 7 times 3 squared. It's lesson 63. We're going to do this, I think, in three parts. Whoa, we're getting blurry there. Today we're going to talk about what is the unit circle, and we're going to talk about how to convert between degrees and radians, or radians and degrees, or whatever you want to do. So let's start our story with doing a little geometry. Some of you had geometry. You may have passed geometry, and that's probably pretty amazing. You know that geometry, we start with just basic stuff like that's a point. And then I'm just going to go over here, I'm going to draw another point. Isn't that crazy? It is. And then I'm going to do that crazy thing in geometry. I'm going to connect those 2 points and make a line segment. And then I'm going to take out my imaginary set of compasses. And I would do it with this one, but it won't actually draw, right? And I do this thing, and I whip around a circle. Here we go. Oh, it got worse as I was doing that, didn't it? It's like turned into flame circle. That's pretty good. Oh, you already did this lesson, so you're not watching your own lesson. It's for the other class. They're behind you. Now, be quiet. I'm filming for educational purposes. That there, my friends, is a circle. Circle is defined as all the points that are equidistant from the center point there. And I just decided that radius was going to be 1. So this is going to be awfully convenient for us because if we set that radius equal to 1, we can do a lot of math. We can do lots of stuff with triangles and circles and angles and stuff that we would have to have a bunch of extra stuff in if that radius wasn't 1. So this right here is called the unit circle. Uni means 1, so it's a circle with a radius of 1. All right, I just constructed it using the tools of geometry. That's how the ancients would have done it. But there came a time when Rene Descartes said, let's put that on a coordinate plane like this. Let's take our unit circle and put it on a regular grid of x's and y's. And he algebratized geometry. And we would have here now, if this was on a regular grid thing of x's and y's, this thing now has an equation in algebraic form. And it's based off of the Pythagorean theorem, which says that if I were to draw a triangle in here, it would be a squared plus b squared equals c squared. That would hold true. Well, anywhere that you draw a triangle here, the radius is 1. So no matter what this x and this y happen to be, what is always true about this circle is that x squared plus y squared equals 1, and that is the geometric algebraic formula for a circle. It is a special case of the Pythagorean theorem, which has to do with triangles, but circles work too. We're going to use this fact here to derive all kinds of beautiful things about this unit circle business. But I picked a couple places here on this. I picked 30 degrees, and I found out what the coordinates would be at 30 degrees for that triangle. And if you square 0.866 and you add that to the square of 0.5, you will get about approximately 1. So any coordinate around this unit circle, if I take the x part and I take the y part and I square them and add them together, I will get 1. Beautiful. Beautiful. Tint. Right. Now, let's take this point right here in particular. Actually, I'm not going to use that point. I'm going to use over here on this circle. And I'm going to go right here, and I'll put that point. I want to know what the coordinates are for that point right there. So what I'm going to do is going to make a triangle out of that. This has a radius of 1. And then I'm going to drop a 90 right there. So that I've got this distance here being x, and this distance right here being the y distance. And using Pythagoras, we would have to say that whatever x squared is and whatever y squared is, we add them together, we get 1. Now I already know that that's a 30-degree angle. These are basic laws of trigonometry. We would say that we could use the sine of 30 degrees as being the y side compared to 1, or the cosine of that 30-degree angle would be equal to the x side over 1. And because we're doing it over 1, we don't even need an over 1. And that's going to be true for any angle that we want to put in there. So we can simplify this and just say that the sine of any angle theta will equal the y-coordinate at whatever place we're on this circle, and that cosine of any angle around this unit circle will be the x address of any point on that circle. So this point up here has the address for this particular angle, cosine of 30 degrees, comma, the sine of 30 degrees, which is approximately 0.866 and 1/2. You can try that on your calculator, but that's what it is. And then in general, any point on this unit circle, no matter what this angle is, has the address cosine theta sine theta. All I need to know is the angle. I don't need to know the lengths. I could figure those out. And so you can see up here on this one, that's what I've written. Cosine sine is the address of any point. All we need to know is the angle on the inside that we rotated the point 1, 0. If I rotate it 90 degrees, the answer is cosine is 0, and the answer for sine is 1. This is the beauty of the unit circle. Are you fascinated yet? Are you having warm, fuzzy mathematical feelings inside of you? Maybe it's a little bit lower down here, like indigestion or something? Yes. Probably. Yes.
Oh, yeah.
What else do we got here? Radian. We're going to use the symbol Greek letter TH. Will mean an angle. But we are going to stop thinking about this angle in terms of degrees. We're going to start thinking of it in terms of another form called radians. Radians. I will describe to you in just a sec what radians are. What's the question?
Did they actually have on this? Oh, he's already here.
I'm recording.
Oh.
And I told him, come to my room. I told you, come to my room. So just come to my room. And be quiet, because I'm recording your lesson. Now, where was I? Oh yeah, we can measure things in other things rather than degrees. So let's talk about that. What we've got with our friend here, the unit circle, is a radius of 1 unit, and I've got out for myself. Well, some of you know what this is. Yeah, pizza time, right? Let's do some pizza at home. I don't want any silly questions. Where do I need to be? And, oh, there we go. Let's get an approximate stab right there. Radius of 1 unit. Okay? 1 unit on the pizza thingamabobber. So I'm just going to put a 1 right here for the radius, my friend the radius. And I have a special tool that I put somewhere, and it's called ruler, and I can't find it. Where did it go? I'm only 43 and I can't find things. This is going to be bad when I get old. Okay, so I'm going to take my radius here, and I'm going to start measuring around the outside of this circle. Radius. There's about 1 radius around the end. The outside. And I'm going to keep going just for fun. And I get 2 radiuses. And let's keep going. There's about 3 radiuses. That's about that. And then I got this little extra bit here. Now, this radian thing, this other way of measuring angles, is how far did I have to go around the outside of the circle in kind of that slippery way? From here to about here. That was the same distance as one radius, and that's called a radian. So a radian is the same distance on the outside of the circle as your radius, and see how convenient it is if that's just a 1. Because the circumference all the way around this circle is pi times twice the diameter, or pi times the diameter, which is twice the radius. If I could rearrange this a little bit, I'm going to have 2 pi times r, and our r is 1. And so the total distance around this circumference is 2 pi times 1, which is approximately 6.28 of these radians. And again, we went 1, 2, 3, 4, 5, 6, and then this part right here is about 0.28 of those. So the circumference, the angle all the way around this circle, the angle itself is 6.28 radians, or 2 pi radians. That means that is equal to going around the circle 1 time, which is 360 degrees. This over here is if we're going to measure this in degrees, the old-fashioned way, and this is if we're going to measure this in radians. We tend to give these answers in parts of pi's, 2 pi's all the way around. So if we only go halfway around the circle and we stop, we have gone pi radians of the way around the circle. 1 pi, 2 pi, 3 pi, 4 pi. That means if we stop right here and go only this far, we've gone half of pi, that's half of 180. If we stopped right here, we would have only gone a fourth of the distance to get to pi radians. Another quick, easy way of relating these things is to say that pi radians equals 180 degrees, which is equivalence here, which means we can turn this into a unit conversion type of thing. We can say pi radians is equal to 180 degrees. Or we could say 180 degrees is equal to pi radians. We're going to use this as we convert from degrees to radians and radians to degrees. Let me demonstrate. Demonstratum, QED, what time it is. So let's say that we're over here in, let's pick something easy, 120 degrees. We like to say what that's equal to in radians. We're going to do this. We're going to say, put the degrees down here, and the radians right here, and we're not going to fiddle with that pi button on our calculators. We're just going to let that sit there. So basically we have the fraction 120 over 180. The degrees will cancel out. We'll multiply that by pi, and we'll be in radians. So cancel out those zeros. We got 12/18 is 2/3 pi, or we might write it like this, 2 pi over 3, or I might say 2 pi on 3 radians. Where is that? It's right over here. It is 120 degrees, or 2 pi over 3 radians. If you take that unit circle thing that I gave you, you can see over yonder, we've got 2/3 pi over here equivalent to 120 degrees. That's how you would convert going from degrees to radians. We would use this particular thing right there, leave the pi there, and do this fraction to convert over to radians. You want to go the other direction? Radians 2 degrees. Like, let's use pi over 6 radians. We're going to put our pi radians down here. We're going to put our 180 degrees right there. And the pi's will cancel out. We'll have 180 degrees over 6. Do that, be 30 degrees. Another quick way to do it when you are going from radians to degrees is if we had something like 3 pi over 4 radians. I'm just going to take out the pi. I'm going to put in 180 degrees because they're equivalent to each other and do that quick math. 3/4 pi is 135 degrees. We got a whole bunch of people here that I can't show you in my video. We are probably not social distancing well, but we'll get to that soon. I think that's about all that I'm going to cover for now. You definitely want to have this in there, these two conversions, how to go from degrees to radians and how to go from radians to degrees. I'm sending you with Reteaching 63. It's in your envelope, those of you who are actually in the room right now. And you're watching this amazing video as well. Go back and review something. If you missed something, hit pause and draw it on there. We're going to have 2 more on the unit circle where we'll explore how in the world we could memorize all this stuff and where all these numbers come from. But you're going to be a better person for it. Okay, remember to wash your hands and to clean your cell phone 3 times a day. All right, if you have questions, pop on in or send me a video or talk to me on the phone or a text or something like that. I have 2 people raising their hands. Do I need this on video or can I just turn it off first? All right, see you later, bye.